Hello and welcome to Unacademy, a one-stop destination for all English medium UPSC aspirants. Welcome to one more session of UCAN. The session covers important science and technology current affairs from the last few weeks. But before we continue with the session, a very important announcement. We are conducting the last Unacademy Civil Services Championship test of the year 2024. And the test is going to happen on 29th December at 11 a.m. and 5 p.m. And the test can give up to 90% scholarship. The test can give up to 90% scholarship for the learners who are preparing for 2026 Civil Services examination. And the students preparing for 2025 can use the test to evaluate your preparation. I hope you will make the best use of the test. And these are some of the new batches for UPSC preparation. Let us continue with the session now. The first topic being the disease X. Hope the audio video is clear. You're able to hear me? The audio video. Good evening. Good evening, all of you. Yes. Right. And hope all of you makes the best use of the Unacademy Civil Services Championship test. And I don't want you all to miss the 90% scholarship. And at the same time, the students who are writing the exam this year can also use the test to evaluate your preparation. Let us continue with the session. The first topic we are discussing is disease X. Okay. Any idea what is disease X? The disease X is not actually a particular disease which already caused some deaths or some pandemics or epidemics. It is basically a hypothetical disease. It is basically a hypothetical disease, right? Do we have any disease called disease X? Yes? Message me. Just message me what you know. Do we have any particular disease called disease X? No. We do not have any particular disease called as disease X. It is just a hypothetical disease which is coined by WHO in the year 2018. Okay, what is the purpose? To present the unknown pathogens with a pandemic potential. Okay, so disease X is just a disease, some disease like which we don't know, it's a hypothetical disease which is having a capacity or a potential to cause a future pandemic. Then, what is the current concern? An outbreak in the year December 2024 in Democratic Republic of Congo caused 400 deaths. Okay. What disease is it? Some disease caused 400 deaths in the December 2024 in Democratic Republic of Congo. What disease is it? Is it swine flu or is it COVID-19? Is it some bird flu or is it Ebola? Nothing. We don't know what the disease is. Okay. So this raised concerns of it being the disease X. It means people are being afraid that maybe the disease that caused this 400 deaths can be the disease X, which the WHO is already warning. Okay. Now let us see the historical context of this particular disease. The concept of disease X arose after the West African Ebola pandemic. Yes, all of you answer this question. The concept of disease X or the term disease X was coined by WHO after which epidemic, after which disease outbreak? Yes, after which disease outbreak? After the Ebola disease outbreak, right? Which resulted more than 11,000 deaths. Okay. So after the Ebola outbreak, the WHO wanted to warn all the countries that there is a future pandemic potential. Okay. For that purpose, it coined the term disease X. And probably COVID-19 is the first real instance of the disease X. The term disease X coined in the year 2018, and in the year 2019 we got the COVID-19 pandemic. So the first real disease X could be the COVID-19 pandemic. Okay. Tell me, what is the possible first real disease X, all of you? The first real disease X is COVID-19. Okay. Now, this is WHO's priority pathogen list. What do you mean by priority pathogen list? Means these are some diseases with which we must be careful. It means they have a potential of being the disease X. The diseases like Ebola virus disease, Marburg virus, keep memorizing all the names. Ebola virus, Marburg virus disease, Lassa fever, Nipah virus, Rift Valley fever, okay, Crimean Congo hemorrhagic fever, Zika virus, all these infections have certain problems. What are those problems? High mortality. Okay. So first of all, what is this list? High priority list. WHO prepared this list. What do you mean by priority pathogen list? We must be careful with these pathogens. Ebola, Marburg, Lassa fever, Nipah virus, Rift Valley fever, Crimean Congo hemorrhagic fever, Zika virus, and the disease X. Okay, some hypothetical disease. We should be careful with all these diseases. Fine. Why we should be careful with all these diseases? First reason, they have high mortality rate. It means, okay, the death rate is more of these particular diseases. Plus, they also have a rapid spread. It means they can easily spread from one human being to the other human being. And also, the lack of adequate preventive and therapeutic options. It means we do not have vaccines or drugs, therapy, treatment for these diseases. What makes these diseases dangerous and we should be careful with these diseases? Their mortality rate is high, they can spread easily, and we do not have preventive measures like vaccines or therapeutic options like drugs. So therefore, we have to be careful with these diseases. Then, ecological disruption and the disease X. Okay, can the ecological disruption cause the pandemics, or can the ecological disruption increase the frequency of pandemics? Yes. Let us suppose, okay, due to globalization, urbanization, industrialization, what happens? The cities will start spreading into the forests. Because of this, humans come into close contact with the wild animals, biodiversity. Each species of the wild animals will have their own pathogens that cause diseases in those animals. But due to expanding of the cities into the forests, we are coming into close contact with the biodiversity, especially the wildlife organisms, animals. Because of this, there is a chance that the disease can spill over or cross over from an animal to the human being. Okay. For example, swine flu. Okay. It's a spillover from the pigs to the human beings. Bird flu is a spillover from the birds to the human beings and the other mammals. Okay. And like say for example, MERS is a spillover from the camel to the human beings. Because of the close contact with the wildlife, there is a chance that their pathogens can spill over or cross over to the human beings. And we cause such diseases as zoonotic diseases. Yes, all of you answer this question. What are the zoonotic diseases? The diseases that spread from the animals to the human beings. Okay. HIV, SARS, severe acquired respiratory syndrome, MERS, Middle East respiratory syndrome, and Ebola was closely linked to the ecological disruptions. What are a few diseases that came in the past that came because of the ecological disruptions? HIV, SARS, MERS, Ebola are because of the ecological disruptions, because of the industrialization, spreading of the cities into the forest and all that. It is caused by human activity, deforestation, urbanization, and the climate change have pushed human beings and the wildlife animals closer to each other, increasing the likelihood of the pathogen transmission. Epidemiologists estimate that there is 1.7 million undiscovered virus. All these are can become the disease X. Is it clear? There are total 1.7 million pathogens that we do not know. They are the undiscovered viruses. 1.7 million undiscovered viruses. We don't know about them. They are existing in the wildlife. And many of these viruses have a capacity to infect the human beings. So therefore, we should do a very planned and controlled and sustainable industrialization and spreading of the cities into the forests. We should minimize the wildlife and the human being contact, close contact between wild animals and the human beings. The factors driving emerging diseases. What factors leads to the emerging diseases? First of all, what do you mean by emerging diseases? Okay. If you observe in the recent past, I mean in the last 1 or 2 decades, you could have easily noticed that we are getting the pandemics and epidemics at a higher rate, at a higher frequency, isn't it? Okay, in the last 1 or 2 decades, we are getting many new infections. Every day you open the newspaper. Like for example, I was trying to avoid biotechnology and trying to search for some space technology or nanotechnology or some other topics. But the newspaper is full of infections, malaria, okay, Ebola, disease X, antibiotic resistance. You might have noticed, okay, the newspaper is full of infections. Why like that? Because in the recent past, there is a dramatic increase in the frequency of epidemics and pandemics. Okay. So that is called emerging diseases, newly emerging diseases, new infections which we did not have in the past. What are the reasons for it? One is zoonotic spillovers, that is spillover or crossover from the animal to the human being. And human activities like deforestation, urbanization, agriculture, etc. And risk from antimicrobial resistance. Okay, some of the pathogens are antimicrobial resistant. What do you mean by antimicrobial resistant? Say I got a bacterial infection and I will take antibiotic, a drug that can kill the bacteria. But still, my disease is not getting cured. It means the bacteria are not dying. Despite taking antibiotics, the bacteria are not dying. So that is called antimicrobial resistance. It can also be because of bioterrorism. Like for example, even when the COVID-19 pandemic came, there were many conspiracy theories that it is a bioweapon or a bioweapon. Or if not a bioweapon, there was another conspiracy theory that it is a laboratory leakage. That means they were doing some experiments on in the Chinese laboratory and accidentally the virus got leaked. Either it is a laboratory leakage or a bioterrorism or it naturally evolved, that remains to be a conspiracy theory. We can never find out what really happened. But these are all the possible reasons for the new diseases. If at all a new pandemic comes, these are the possible reasons. Next, global vulnerability. High biodiversity regions. I mean, what regions are more vulnerable to the new pandemic or new epidemics? Okay, the biodiversity hotspots. Because when there is more biodiversity, you have different varieties or different species of the wildlife animals. And each one will harbor a different set of viruses or the pathogens. They all can spill over to the human beings. So therefore high biodiversity regions plus the regions with weak healthcare systems, because even in the case of a few infections, if the country is an undeveloped country, not having a sound health infrastructure, then what happens? A few cases also will become an overload on the health infrastructure, hospitals and all. So therefore, the places where the healthcare systems are weak are also at risk. What kind of places are at risk? High biodiversity regions and the regions where the healthcare infrastructure is not well developed. Okay, right. Then increased interconnectedness through travel and trade also accelerate the disease spread. At this juncture, I would like to discuss the difference between epidemics and pandemics. Okay, yes. Can you tell me what is an epidemic? Yes, all of you please. What is an epidemic? Epidemic is nothing but a sudden outbreak. It means what? Short duration, but more cases or more deaths in a short span of time. Okay, like if more cases or more deaths happen, we can call that as epidemic. Then epidemics are local in nature. Is it clear? They are not worldwide, they are local. Next, what is a pandemic? Yes, all of you, what is a pandemic? Pandemic is also a sudden outbreak, same as epidemic. This is also a sudden outbreak. In the pandemic also, in a short duration, more cases will be reported or more deaths will occur. But the only difference is, this is at the global level. So it means we can call a global level epidemic as a pandemic. An epidemic that occurs at the global level can be called as pandemic. We also have another type of diseases called as endemic diseases. Endemic diseases are not sudden outbreaks. They are the constant worry in one particular region. Like for example, okay, malaria. Malaria is endemic to Africa. Malaria is endemic to Africa. Okay, it is not a sudden outbreak throughout the year. Maybe in the rainy season, the number of cases can slightly increase. Small increase and decrease in the number of cases do occur. But throughout the year, they continue to have this problem, but confined to one small region. That is called as endemic diseases. Okay, so increased interconnectedness through travel and trade accelerate the disease spread. It means what? Let us suppose COVID-19. If there is no worldwide global travel, that is flights, this much of travel and trade between the countries, there is a chance that the COVID-19 could have been curbed at China itself without spreading to all over the world. Due to the increased travel and the trade between the countries, due to the increased connectedness between the countries, there is a chance that every epidemic can become the pandemic. Okay? Due to increased connectivity, what is the risk? Every local disease has a potential of becoming the pandemic. Global spread chances are there. Next, preparation strategies. It means if at all the disease X comes, how should we be prepared? Strengthening the genomic sequencing. Genome means what? The word genome means the complete set of genetic material. Okay, of a cell of an organism. Okay, it means the total set of DNA or the chromosomes that I have in one of my cells. I repeat, the total set of DNA or the chromosomes that I have in one of my cells is called as my genome. Same way, the total set of DNA present in a virus is its genome. Is it clear? Genomic sequencing. Why? Because every new variant, for example, if you take COVID-19, okay, the Omicron variant, beta variant, delta variant, each variant will have a different genome sequence. When there is a difference in the genome sequence, we can identify that this is a new variant. So we should be strong in the genome sequencing. And artificial intelligence. Why artificial intelligence? To analyze the spread of the infection. It means what is the death rate, how quickly it can spread, what maximum deaths can be reported, what maximum cases can be reported, when the epidemic can be controlled. Okay, such information can be analyzed using the artificial intelligence. Plus real-time data sharing and surveillance. Why data sharing is important? Let us suppose a new variant of a virus comes in Africa. They should immediately report it to the total world so that the total world can be alert and prepared. So real-time data sharing, if I discover a new variant or a new virus, immediately I should share the data with the complete world. Enhancing healthcare infrastructure, diagnostic tests, treatment, hospital facilities, oxygen cylinders, all these things must be prepared. So we should have strong healthcare infrastructure, particularly in the low economic countries, right? Then organizations like Coalition for Epidemic Preparedness Innovations, CEPI, are now investing in a prototype pathogen. Prototype pathogen is the disease X platforms that can be adapted to target unknown diseases within 100 days after their identification. It means what? The Coalition for Epidemic Preparedness Innovations, CEPI, an organization called CEPI, is making arrangements that if at all we discover a new virus, within 100 days, we should be able to control it. Okay. CEPI is making arrangements that if at all in future we discover a new virus or a new pathogen, we should be able to control it within 100 days. That kind of preparedness CEPI is trying. Next, global collaboration needed. Why global collaboration needed? Because I told you presently we are living in a global village. All the countries are interconnected. Okay. So any event that happens in one place in the world can impact the total world. So therefore we need global preparedness. Only rich countries are prepared for the pandemic is not sufficient. Okay, how much ever they are prepared, how much ever advancement they have in the healthcare infrastructure or vaccines or whatever therapies or whatever it is, but if the disease comes in an undeveloped country, then those countries also will get affected. The WHO's ongoing efforts such as list of priority pathogens. What is the list of priority pathogens? Already we have seen Ebola, Marburg, Lassa, Nipah, Rift Valley fever, Crimean Congo hemorrhagic fever, Zika virus. All these are in the priority list. Okay. And also a pandemic treaty. Do we already have a pandemic treaty? No, we do not have an existing pandemic treaty. There is a proposed pandemic treaty that all the countries should sign. Okay, so that we are agreeing for like a collaborative, okay, that is cooperative approach to control such pandemics in future. Aim to foster a unified global response. It means isolatedly whatever effort that I keep in India is not sufficient. We need a global framework. Okay, we need a unified approach, collaborative approach. Okay, frameworks like Nagoya Protocol. Use the word once, message me that Nagoya Protocol. What is this Nagoya Protocol? You know, Convention on Biodiversity. Convention on Biodiversity. Okay, CBD, Convention on Biodiversity. Okay, it will conduct conference of party meetings, conference of party, COP meetings, once in every 2 years. The 10th COP meeting, okay, they made this particular protocol. In the 10th COP meeting, they made this protocol called Nagoya Protocol. In this protocol, all the conference of parties, it means all the party countries agreed to ensure equitable sharing of the benefits from genetic resources. What is genetic resources? For example, in India, we have a data of lakhs of new viruses genomes. Is it clear? Genomes of several viruses, we have a data. So that is a genetic resource. That is data is a new resource, isn't it? It is a new gold, right? Okay. So if we have data about the new viruses genome sequences, that is a genetic resource. All the party countries agreed for equitable sharing of the benefits of genetic resources. This Nagoya protocol should be extended to the pathogens as well. Earlier it was applicable more for the human genomes, but now we have to increase, we have to extrapolate this particular protocol to even for the pathogens also. We should share the genetic resources of pathogens as well. Is it clear? So this is about the disease X. Now, I'll give you some around 30 to 40 seconds time. Solve this question and message me the answers. Some of you say D, some of you say A. Right. Others, please, everybody. Okay. Majority says D, and yes, D is the right answer. Let us discuss the question. Disease X is a placeholder. Placeholder means it is keeping a place. X is a vacant slot. In the place of X, you can fill it with a new name, like it can be COVID-19 or it can be some other disease which comes in the future. It is a vacant slot. It is a placeholder for unknown pathogens with pandemic potential. Unknown pathogens which have a capacity to cause a future pandemic. Correct. Okay. The concept of disease X was introduced by the WHO in response to COVID-19 pandemic. No, wrong. Actually, the term disease X was coined in 2018 and the COVID-19, the name itself is indicating that this is a disease that came in the 2019. And COVID-19 is the possible first disease X. Is it clear? The term disease X is not coined in response to COVID-19. But after the term is coined, COVID-19 could be the first real disease X. I hope the difference is clear. Okay. The term disease X is not coined after COVID-19, but after coining the term disease X, the first disease X could be the COVID-19. So this is wrong statement. Next. HIV, SARS, MERS and Ebola are closely linked to the ecological disruptions. We got those diseases because we are damaging the ecology, ecosystems. Yes, correct. This is correct. CEPI is a platform for equitable sharing of benefits from the genetic resources. No, this is true for what? This is true for Nagoya Protocol. Is it clear? This is not true for CEPI. What is CEPI doing? Okay, making preparations to control the pandemic within 100 days after identification. Today you identify a new disease. You should be able to control it within 100 days. That is the target of CEPI. This is not a platform for equitable sharing of benefits of genetic resources, and that is Nagoya Protocol. So 1 and 4 are wrong. Okay. And 2 and 4 are wrong. 1 and 3. Okay. D is the right answer. Done? Right. Now, moving on to the next topic, that is nanoplastics identified as emerging agents in the spread of antibiotic resistance. Okay, it means the plastic bottles that we drink water and just carelessly throw wherever we want, in the oceans, in the rivers, in the parks, or in the forests, on the mountains, wherever we want, we are carelessly throwing those plastic bottles. In general, you all might have studied about the disadvantages and the problems caused because of the plastics. Now, this is a new problem identified. This is another new problem this is one more new problem because of the plastics. We know several problems because of that. Okay, but this is one more new problem. What is that? It can also cause antibiotic resistance. Let us see more about it. Nanoplastics, it means the plastic bottles that we are throwing will undergo degradation. They will break down into small particles of the nanometer size range. So those are called as nanoplastics. They are derived from the single-use plastic bottles. Okay, they are derived from the single-use plastic bottles that we use for cold drinks, water bottles, and all those things. They contribute to the spread of antibiotic resistance by impacting the bacterial behavior. Okay. The nanoplastics facilitate, these nanoplastics are acting like carriers to carry the antimicrobial resistance gene from one bacterium to the other bacterium. Okay. Let us try to understand how this happens. Let us try to understand how this happens. Let us suppose this is a bacterium. Called A, and this is another bacterium called B. Okay, then in this there is an antimicrobial resistance gene, means a gene that cause, okay, this is mainly from the single-use plastic bottles, Nishant, mainly from the single-use plastic bottles, because they quickly undergo degradation, not disintegration. They'll break down into small particles. Okay, look at this. What is present in the first bacterium? A gene which is responsible for antimicrobial resistance. That means because of this gene, even if you add antibiotics to this bacteria, the bacteria will not die. What is the problem with that? Normally, if you get some fever or any infection, what we do? We take some amoxicillin or some kanamycin. We simply take a tablet and within 1 week the disease will get cured. It means the antibiotics are killing those bacteria. But if the bacteria have this gene, they have a capacity to resist the antibiotics. Despite taking antibiotics, the bacteria will not die and the disease will not be cured. So that is an antimicrobial resistance gene. Okay, now let us assume that this is the nanoplastic. Okay, let us suppose this is the nanoplastic. Right? The nanoplastic, what it is doing is, it is carrying the AR genes. I hope you understood the mechanism. AR genes. Okay. From one bacterium to the other bacterium. From one bacterium to the other bacterium. Is that clear? The nanoplastics that are derived from the single-use plastic, these are nanometer size ranged plastic particles. They act as carriers. I mean the AR genes are swimming in the water. The AR genes are swimming in the water, or they are using them as boats. Is it clear? They are using the nanoplastic particles as boats, and they are traveling from one bacterium to the other bacterium. So now tell me, before the AR gene transferred from one bacterium to the other bacterium, is the bacterium B, was this bacterium resistant to the antibiotics before the transfer? Yes. Before the transfer, was this bacterium antibiotic resistant? No. But after the transfer, this bacterium also became antibiotic resistant. It means because of the nanoplastic particles, the bacteria that are not antibiotic resistant are also becoming antibiotic resistant. Is it the bacteria which are not naturally antibiotic resistant are also becoming antibiotic resistant? More and more bacteria will become resistant to antibiotics. It means we cannot cure the diseases. Just imagine such a situation. That is one more reason why we should not use the single use plastic bottles. But in my opinion, okay, individuals can do little. I mean, the government should totally ban the single use plastic bottles. In our childhood, we used to carry glass bottles or steel bottles, or okay, multiple use plastic bottles. I mean, one complete year we used to use that same water bottle. Okay, so if the single use plastic bottles are not available in the market, automatically this can be controlled. Is it clear? Okay, then now let us see what are the different mechanisms through which AR gene can transfer from one bacterium to the other bacterium. First one is called as direct transformation. But before I explain this, let me explain these three mechanisms. Okay, if possible, all of you use these three words: transformation, transduction, conjugation. Transformation, transduction, and conjugation. Okay, use the three words, all of you. Right. In transformation, what happens is, from one bacterium, okay, the AR gene, okay, directly goes, okay, this is step 1. Is it clear? This is step 2. Okay, the AR gene directly goes from one cell to the other cell. Is it clear? From one bacterium to the other bacterium. Is it clear? Step 1. From the first bacterium, the antimicrobial resistance gene came out. Now it is in the water. Step 2. The second bacterium will take up this gene directly from the surroundings, from the environment. The other bacterium will take the gene from the environment. Then we call it as transformation. I hope the transformation is clear. Next we have transduction. What is transduction? Same, one bacterium. This is having the AR gene, and the other bacterium, it is not having the AR gene. Now what happens is, okay, a virus will infect the first bacterium. What is this? This is a virus. And what is this? This is a bacterium. Is it clear? Okay, a virus will infect the bacterium. And now the virus will get the AR gene. Step 1. Step 1. AR gene, that is antimicrobial resistance gene, goes from the bacterium to the virus. Is step 1 clear? The gene responsible for antibiotic resistance goes from the bacterium to the virus. Step 2. The virus will carry the antimicrobial resistance gene, okay, to the other bacterium. Is it clear? The virus will carry, now the virus will infect the other bacterium. Step 3. Now the AR gene is in the other bacterium. It means transfer of gene, one bacteria giving the gene to the other bacteria through a virus is called as transduction. Is transduction clear for all of you? If one bacterium takes up the gene from the other bacterium directly from the environment, directly from the surroundings, then it is called as transformation. Okay. There is one more mechanism called as conjugation. Is it clear for all of you? The other mechanism is called as conjugation. Conjugation is like a sexual relation between the two animals. Is it clear? The two bacteria will have a bridge. This is called as the sex pilus. It is called sex pilus. Use the word once. Sex pilus will connect the two bacteria. What is this? This is one bacteria, A. This is another bacteria, B, a different type of bacteria, right? And then the AR gene goes from one bacteria to the other bacteria, not from the surroundings, not by the virus, will directly go from one cell to the other cell through this bridge-like connection between the two cells called as sex pilus. This is almost like a sexual relation between the two bacteria. The AR gene went. That is called conjugation. Okay. I explained you conjugation, transduction and transformation. Now, can you tell me the topic that we are discussing here? That is the nanoparticles. The topic we are discussing, nanoplastic, okay, is carrying the AR gene from, okay, one bacterium to the other. Can you tell me this is, okay, like transformation or transduction or conjugation? Remember, conjugation means direct contact should be there. Kanishak, think about it. Transduction, a virus will carry this. In the transduction, a virus will carry this. Okay. But here is a virus carrying it? No. Okay. They are just surfing using the nanoplastic particles as small boats. Is it? They are enjoying the boat ride. So they are not carried by, okay, the virus. Also, they are not transferring through a bridge-like connection between the two. Okay. So what is a word that you can give? Transformation. I hope it is clear. Yes. The topic that we are discussing is an example for conjugation or transformation or transduction or none of the above. It is transformation. Okay. Right. Where nanoplastics act as carriers for AR plasmids between the bacterial species. From one bacterium to the other bacterium, they are carried through this particular, okay, nanoplastic boats. Next. Transduction. Next, one more thing is polyethylene, okay, terephthalate bottle-derived nanoparticles. Okay, what is this? This is the chemical present in the single-use plastic bottles. Is it clear? Polyethylene, terephthalate, bottle-derived nanoplastics. What is that? That is the name of a chemical that we have in the single-use plastic bottles. Okay, this chemical, what it will do is, listen carefully, complete focus. Okay, this chemical, what it will do is, it will cause oxidative stress. It means, let us suppose this is a bacteria. Is it clear? It's a bacteria. There is AR gene in this. There is AR gene in this. Now what is happening? This PBNP bound to it. Okay, the PBNP bound to it. What it will do? It will cause stress. It means now our bacteria is under the pressure, getting tensed, is like its BP is increasing. Now it is in the stress. What kind of a stress? Okay, oxidative stress. I mean, it will cause oxidation of the bacteria. Now, when this bacteria is in the stress, what it will do is, as a stress response, okay, what happens is, there is an increase in the outer membrane vesicles. I mean, this is the outer membrane of the bacterium. Look at this. This is the outer membrane of the bacterium. That from that, small vesicles, okay, OMV. What is OMV? Outer membrane vesicles. Outer membrane vesicles. Okay, I repeat, there is one bacterium. It has AR gene. Now PBNP bound to it. That is polyethylene tetraphthalate bottle derived nanoparticles bound to it. They cause oxidative stress to the bacterium. Now the bacteria which is under the stress will start secreting, will start releasing the outer membrane vesicles. This outer membrane will break down and will form small vesicles. Now these vesicles will have AR gene. I hope you understood this. The vesicle will have AR gene. And the vesicle will carry this particular gene to another bacterium. Is it clear? A different bacterium. Clear? Now, this is also like transformation because there is no bridge like sex pilus between the two bacteria here. And it is not a virus. This is not a virus. It is outer membrane vesicle of the first bacteria. Okay. It is carrying the antimicrobial resistance gene to the other bacterium. So this can also be called as transformation. Do you agree? Can I call it as transduction? No, because virus is not carrying the gene. What is carrying the gene? A vesicle coming from the first bacteria is carrying the gene. Okay. Can I at least call this as conjugation? No, because there is no bridge like sex pilus between the two bacteria. So this should also be considered as one particular type of transformation. Okay. These outer membrane vesicles loaded with the AR genes become potent vectors. Vector means carrier. This is a vector. The word vector means what? Carrier. Okay. It will carry the antimicrobial resistance gene to the other bacteria. Next point. Beneficial gut bacteria. Actually, in one of our earlier UCAN sessions, we discussed about gut bacterium. What is gut? Our digestive system. Small intestine, large intestine, stomach. This together, the alimentary canal is called as the gut bacterium. Our complete gut. Most importantly, the intestine contains so many friendly bacteria. In fact, we have more bacterial cells in our body than our own cells. It means like I have more bacterial cells in my body when compared to my own cells. One of such friendly bacterium is Lactobacillus acidophilus. Use the word once. Lactobacillus acidophilus. I hope others are getting clarity. Any doubt? Manu Sharma, if you have any specific doubt, you can ask me. It's quite an easy topic, simple. There is a gene that causes antimicrobial resistance. It is going from one bacterium to the other bacterium. If it goes to the other bacterium also will become resistant to the drugs. Is it clear? That's it. Now we are discussing what is carrying that particular antimicrobial resistance gene. If it directly goes, transformation. If the gene is carried by a virus, transduction. If the gene is carried by a sex pilus, like a bridge-like structure, conjugation. Now, okay, nanoplastics, what are they doing? Okay, one mechanism quite easy. The AR genes are surfing on the plastic particles. Plastic particles are acting as vectors. They carry the antimicrobial resistance gene from one bacterium to the other bacterium, so that the other bacterium also will become resistant. I mean, more bacteria are becoming resistant to antibiotics. Okay. The other mechanism is these plastics, PBNP. It is a chemical in such plastics, single-use plastics. It will cause stress in one bacterium, and the bacterium which is stressed out will release small vesicles. Vesicle means what? Small bag-like structure. The word vesicle means a small bag-like structure. The bacterium which is stressed will release more such vesicles, outer membrane vesicles. What do you mean by outer membrane? This is the outer membrane of the bacterium. It will release small bag-like structures. What is present in that bag? Antimicrobial resistance gene. And this vesicle, that is this bag, will carry that resistance gene to the new bacterium. And the new bacterium also became resistant to the antimicrobials or antibiotics. Okay. Here it is not carried by a virus, not carried by the sex pilus. There is no direct contact between the two bacteria. So this is also a type of transformation. Okay. I hope it is clear, Manu, and also for everybody. Right. With that, the different mechanisms of how the antimicrobial resistance gene is going from one bacterium to the other bacterium is completed. Now what we are discussing is, in our body, that is in our digestive system, there is a friendly bacterium. Means a bacterium that will help us. It is not a pathogen. It will not cause diseases. Okay. So, one such example is, we have many such friendly bacteria, but one such example is Lactobacillus acidophilus. What it can do? It is acting as a reservoir for antibiotic resistance genes. Lactobacillus acidophilus is acting as a reservoir for antimicrobial resistance gene, antibiotic resistance genes. And then it will give these genes to any pathogen that infects. It means, let us suppose I have Lactobacillus acidophilus in my body. I repeat, I have Lactobacillus acidophilus in my body. Point number 2, it is acting as a reservoir for antibiotic resistance genes. I mean, it is holding all the antibiotic resistance genes. Point number 3, now I got infected by a pathogen. I mean, a disease-causing bacteria infected me. Now, the antibiotic resistance gene will go from Lactobacillus, that is my friendly bacterium, to the pathogen that is causing disease in my body. Okay. The antibiotic resistance gene is going from the Lactobacillus to the pathogen, disease-causing bacterium. Now the disease-causing bacterium became antibiotic resistant. Is it clear? I repeat, I have Lactobacillus acidophilus in my body. It is acting as a reservoir. I mean, it is holding several antibiotic resistance genes, AR genes. Now I got infected by a new bacterium. Now the AR gene will go from Lactobacillus acidophilus to that pathogen, the disease-causing bacterium. Because of this, the disease-causing bacterium also became resistant to the antibiotic, so that I cannot cure my infection. That is one problem. I hope the problem is clear for all of you. Right. The findings highlight the connection between plastic pollution and antibiotic resistance. In summary, what all we understood from this article? Okay, plastic pollution is causing one more threat, that is increasing the antimicrobial resistance. Because of this plastics, more and more bacteria are becoming resistant to the antibiotics. Is that clear? Now, I'll give you some 30 to 40 seconds time. Solve this question and message me your answers. All of you, please. Very good. Most of you are giving the right answers. Very good. And also thank you so much for your active participation. Right. Nanoplastics can facilitate transfer of AR genes among bacteria through conjugation. Wrong. Then through what? Through transformation. Right? Through transformation. Conjugation is a direct contact between the two bacteria. You don't need nanoplastic carriers for that. Beneficial gut bacteria, that Lactobacillus acidophilus. The beneficial gut bacteria can become reservoirs of AR genes due to the nanoplastic exposure. Due to nanoplastics, all AR genes are getting accumulated in our friendly bacteria. Yes, correct. Nanoplastics can increase the rate of mutation forming the new AR genes. No, they are just carrying the genes. They are not causing the mutations. Okay. So 2 only, B is the right answer. Clear till now? Right. Moving on to the next topic. The next topic is about Indian scientists develop novel gene therapy. Okay. For hemophilia. So, let us first try to understand what is hemophilia. Okay. In hemophilia, what happens is there won't be blood clotting. So, blood clotting will be absent. So, these people will be severely bleeding. That is a problem in hemophilia. Is the problem clear? But why this occurs? Because in our blood we have approximately 13 blood clotting factors. We have 13 blood clotting factors. Blood clotting factors means some proteins that are responsible for the blood to clot. If we do not have these factors, then our blood cannot clot. In that case, what happens? Very frequently, we keep bleeding. Bleeding outside, it can be from the nose, it can be from the ears, or it can be internal bleeding. Okay? Why? Clotting factors are absent. Then, hemophilia is 2 types. In hemophilia A, the clotting factor number 8. Okay, not 8 factors, only 1 factor. The 8th one is missing. Then also the blood cannot clot. Then the second type is hemophilia B. In this, the clotting factor number 9 is missing. Then also the blood cannot clot. I mean, the reason is different, but the effect is the same. What is the effect? Their blood will not clot. Okay, therefore there will be several bleeding episodes. I mean, once in a week, once in a month, they will be bleeding. That is a problem. Out of these two, this is more common. Hemophilia A is more common. Okay, tell me, hemophilia A is more common or hemophilia B is more common? All of you, please. Hemophilia A is more common. Okay, think hemophilia. Right. Now, okay. Also, hemophilia A is more common in the males. In males, it is more common. In males, it is more common. Why? What is the reason? Why this is more common in the males? You know, what are the sex chromosomes in the females? In the females, the sex chromosomes are XX, right? In the males, the sex chromosomes are X and Y. The sex chromosomes are X and Y. Then, hemophilia, listen this carefully. This is slightly deeper concept, okay? And complete concentration, please. Hemophilia is an X-linked recessive disease. Recessive disease. Use the word once, all of you. Hemophilia is an X-linked recessive disease. Recessive means what? It is weak, can be easily dominated by something, isn't it? Dominant means strong. It can dominate the other. Recessive means what? Weak. It can be dominated by the others. Is it clear? For example, small h. A particular gene called small h cause hemophilia. Is it clear? Small h cause hemophilia. Name the gene that cause hemophilia. All of you name the gene that cause hemophilia. Small h. Right. But if the other chromosome, if the other X chromosome is having capital H, for example, if the other X chromosome is having capital H, all of you tell me, can the capital H dominate the small h? Can the capital H dominate the small h? Right? Because capital H is a strong gene, dominant gene. Small h is a weak gene, recessive gene. So the dominant gene will dominate this one. So therefore, they are normal. They are normal people. I mean, they do not suffer from hemophilia. Okay? They do not suffer from hemophilia. No hemophilia. Is it clear? I hope you are able to understand this. But if it is a male, let us suppose a male individual is having small h on the X chromosome. Okay, all of you answer this please. A male is having small h, that is the gene that causes hemophilia, is present on the X chromosome. But is the male having another X chromosome or not? The other one is a Y chromosome. Is the male having another X chromosome? Yes? No, there is no other X chromosome. They have Y. And the Y chromosome do not have the H gene. H gene is absent on Y chromosome. H gene is not there on the Y chromosome. It means no one to dominate, isn't it? There is no one to dominate the small h. I repeat, small h cause hemophilia. In the females, there can be a capital H on the other X chromosome to dominate the small h. So, they rarely get hemophilia. But in the male, there is no other X chromosome carrying capital H to dominate the small h. Nobody to dominate. So, the small h will express. It means they can suffer from hemophilia. This is the reason why, because it is an X-linked recessive disease, it is more common in the males when compared to the females. In females, the other dominant H gene can suppress this one. Do not let the hemophilia disease to occur. Do not let the small h to express. Is that clear? Okay. Scientists in Tamil Nadu successfully treated 5 patients with severe hemophilia A using gene therapy. Gene therapy means what? Okay, see, let us suppose, okay, I have hemophilia. Okay, I have hemophilia. Okay, means I'm having frequent bleeding episodes. Okay, internal bleeding. Okay, now, why reduce the size of it? Okay, right, let us see from the next class, Nishant. Okay, let us focus on the subject now, because now I cannot do it. Okay, So like, let us suppose a person is suffering from hemophilia. Okay. Tell me what is absent. It is hemophilia A. All of you tell me. Nishant, tell me. What is missing in this person? Some factor is missing in this person. What is missing in this person? Why is he suffering from hemophilia A? Okay. All of you please. Factor 8 is missing. Isn't it? Factor 8 is missing. Okay. Now, what is one solution? Tell me what is one solution. Look at here. The traditional treatment. The traditional treatment includes repeated factor 8 replacement or injections. Is it clear? I have hemophilia A. It means factor 8 is missing. I don't have factor 8. So what is the solution? Give the factor 8. By the way, what is factor 8? It is a protein. Is it clear? Factor 8 is a protein. Clear till now? Plus. Or else what we can do is, instead of giving factor 8, give any substance that mimics the factor 8. I mean, you are not injecting factor 8, but you are giving some chemical which in the structure it is like factor 8. Then also we can stop bleeding. These are the traditional treatment options for hemophilia. I repeat, I have hemophilia A. So factor 8 is missing. One solution is inject the factor 8 protein. If that is not available, inject some chemical that mimics the factor 8 protein. This is a traditional treatment procedure. Can I call this as gene therapy? Can I call this procedure as gene therapy? No, because we are not injecting the gene. We are injecting a protein. We are injecting a protein. So we cannot call it as gene therapy. It is traditional treatment. Okay, then you may ask me one doubt. What is the link between gene and protein? All of you remember? Okay, can you tell me what is the link between gene and protein? Gene will produce the protein. It means, okay, factor 8 gene produce factor 8 protein. Okay. So all of you tell me what is the relation or the link between the gene and the protein? Gene produces protein. For example, factor 8 gene produces factor 8 protein. So now tell me, in this traditional treatment options, are we injecting the factor 8 gene or the factor 8 protein? All of you please. In the traditional methods, are we injecting the factor 8 gene or factor 8 protein? We are injecting the factor 8 protein. Then, okay? Right. Okay, we are injecting the factor 8 protein. Now, in the gene therapy, we should inject the factor 8 protein or the factor 8 gene. All of you please. In the gene therapy, what we have to inject? Factor 8 gene. But in the traditional methods, what we are injecting? Protein. If the protein is also not available, we are injecting something that mimics the protein. So now tell me, is a traditional treatment method a permanent solution or a temporary solution? I mean, you have to repeatedly give the factor 8 injection or single time injection. We should repeatedly give the factor 8 injection or a single time. Temporary. We have to repeatedly give the injection because we are not solving the problem at the root cause level. What is the problem? My factor 8 gene is not working. My factor 8 gene is not working. So what is the solution at root cause? Replace the gene. If you give the protein, it's fine, temporary relief, but you should keep on giving the protein injection repeatedly because I don't have the gene, I cannot produce it. Next day also, I have to take the injection itself. Is it clear? But is gene therapy permanent solution for the hemophilia A? Is gene therapy a permanent solution for the hemophilia A? Yes, all of you? Yes. Let us suppose I have hemophilia A. Reason is my factor 8 gene is not working. But you have given me factor 8 gene, not the protein. You have directly given me factor 8 gene. It means you solved my problem at the root cause level. Now next day I need not take factor 8 injection. I can produce factor 8 on my own. Is it clear? Okay, so that is gene therapy for hemophilia A. Now, why this is in the news? Why are we discussing about it? Recently, Tamil Nadu scientists have discovered a new gene therapy for hemophilia A. Is it clear? Why is this in the news? Recently, the scientists from Tamil Nadu have discovered a new gene therapy method, okay, for this particular, gene therapy, okay. Nothing, Mumtaz, I will repeat it, nothing, okay. Gene produces protein, Mumtaz. For example, insulin gene produce insulin protein. Hemoglobin gene produce hemoglobin protein. It means gene is the precursor or gene is the source. Gene is the source. Protein is the product. Is it clear, Mumtaz? Gene produces protein. Factor 8 gene produces factor 8 protein. Factor 9 gene produces factor 9 protein. Insulin gene produces insulin protein. Gene is a source. Product is the protein. In the traditional methods, we are injecting the product, but that is not a permanent solution. Because as long as I do not have the source, you should keep on giving me the product. I mean, as long as I don't have the gene, you should keep on giving me the clotting factor 8 protein. I cannot produce it because I don't have a gene for it. So Mumtaz, what is the final solution? You give me the gene only. You give me the source so that I don't have to take the protein injection. I can produce the factor 8 in my body itself. I can produce factor 8 in my body itself. Mumtaz, I hope it is clear and I hope it is clear for all of you. Right. So, traditional methods inject protein. Is it clear? Yeah, in the traditional methods, no production, only import from outside. But in the gene therapy, we are giving the gene. I mean, I'm giving you the source. I'm correcting the problem at the root cause level. Now I got the factor 8 gene, so I can produce factor 8 protein in my body itself. I don't have to take an injection again. It is a permanent solution. Is it clear? Okay. Right. See, that is the reason why I'm drawing all these things. We don't have images. Okay, like in the newspaper, there is no image for all these things. So I know the images will help you. So that is the reason why I am drawing it for you, right? Okay? Right. So, I hope it is clear till now. No. Okay, so why this is in the news? Recently, Tamil Nadu scientists have discovered a new gene therapy. Okay, but is it the first gene therapy for hemophilia? Did Indians discover the first gene therapy for hemophilia? No. There is another one called as Roctavian. Use the word once. Roctavian. What is this? This is the first FDA approved. FDA means what? Food and Drug Administration. FDA approved gene therapy. Is it clear? What it will do? it will use adenovirus vector to deliver the gene. I will explain this using a diagram. Understand this. Okay. Roctavian. What is Roctavian? Roctavian is, okay, this is adenovirus DNA. Is it clear? Plus, in that what we are keeping is, what is this? This is factor 8 gene. Is it clear? Okay. What is Roctavian? Roctavian is adenovirus. What is adenovirus? That is a name of a virus. Nothing to understand. Adenovirus, that is a name of a virus. Okay. Where yellow color portion of the diagram is, okay, adenovirus DNA. Red color part of the diagram is the factor 8 gene. Okay. We are using this adenovirus DNA as a vector. We are using adenovirus DNA as a vector to carry the factor 8 gene. Is that clear? Yes, clear for all of you? Ishwar, I hope you understood. Yes, Ishwar, clear? Right. So we are using adenovirus DNA as a vector. Vector means what? Carrier. To carry the factor 8 gene. So what we are doing is we are giving this. Okay, we are giving this as an injection. We are giving this as an injection to hemophilia patient. Hemophilia A patient. Is it clear? Okay, we are giving this as an injection to hemophilia A patient. Then what happens? His liver, once you, because you are giving the source, he can produce the product. I hope it is clear. We have given him the source. So he can now produce the product. Using that gene, okay, his liver produces. Factor 8 protein. Okay, from factor 8 gene. Is that clear? I repeat once again. Okay, look at this. The yellow color part of the diagram is an adenovirus DNA. We are using this as a carrier. The hero character of our movie is not adenovirus. The hero of our story is factor 8 gene. But we are using adenovirus as a vector, means like a carrier. Now we are injecting this to whom? We are injecting this to hemophilia patient. Now the hemophilia patient got the factor 8 gene source he got the source. Now his liver will produce factor 8 protein from the factor 8 gene. Using the factor 8 gene, his liver will produce factor 8 protein. So you don't have to repeatedly give factor 8 injections. Is it clear? This is the gene therapy called as Roctavian. Is it clear? This is a gene therapy called as Roctavian. No, it is not transduction, Roger. But your thought process is correct. Why it is not transduction? Because it is not adenovirus. It is only adenovirus DNA. If the complete virus is carrying it, we can call it as transduction. Moreover, transduction is a transfer between two bacteria. But here you are giving it from a virus to a hemophilia patient, human being. So we cannot call it as a transduction. I hope it is clear, Roger. Transduction is transfer of a gene from one bacterium to the other bacterium through a virus. Transfer of a gene from one bacterium to the other bacterium through a virus. But here, okay, it is a viral DNA, okay, that we are injecting to human being, not the complete virus, only viral DNA, that too not to a bacteria. We are injecting this to the human being, so we cannot compare, both are different. This is not transduction, it is a gene therapy mechanism. Why this is called gene therapy? Therapy means what? Treatment. Treating a genetic disease using a gene. Treating a disease using a gene is called as gene therapy. Is that clear? Right. So, this Roctavian is the first FDA approved gene therapy. But now the news is Indian trial that is better than the Roctavian. Okay, Indian trial was proven better than the Roctavian because after Roctavian gene therapy, the hemophilia patients still had some bleeding episodes. But after the Indian gene therapy, they did not have any bleeding episodes. So our gene therapy is superior to Roctavian. The difference is instead of adenovirus, Indian scientists have used another virus called lentivirus. Nothing to understand in this. This is just the name of the virus. You have to memorize it. Is it clear? Okay. So now tell me, the FDA approved gene therapy Roctavian uses what DNA as a vector or carrier? The FDA approved Roctavian uses what viral DNA as a carrier? Everybody please. Adenovirus. In the Indian trials, the new gene therapy that is discovered by the Indians, okay, we are using which viral DNA as a vector instead of the adenovirus? We are using which viral DNA to carry the gene, okay, to the hemophilia patient? Lentivirus. Which is proven superior? The Roctavian is superior or the new gene therapy by Tamil Nadu scientists is superior? Our Indian gene therapy is superior when compared to Roctavian. Okay. In what way we can say Indian gene therapy is superior? Because after taking this gene therapy, the patients did not have any bleeding episodes, more successful. But after taking Roctavian, the patients had some bleeding episodes. That is one problem. Plus, Roctavian is not given to the children. Okay, we should not give Roctavian to the children. But the Indian gene therapy can be given to the children also. Much more safer, much more effective, and can be given to the children as well. Okay, so that is the reason why this is very important and very, okay, a proud moment for the Indian scientists to discover the new gene therapy that is more effective than this Roctavian. Right? Now, I'll give you 30 seconds time. Solve this question, all of you, and message me your answers. No, Ishwar, it is in the human beings only. Very good. Thank you so much for answering. Right, let us discuss the question. Roctavian, the only FDA approved gene therapy, uses lentivirus? No. Okay. The Indian trial uses adenovirus? No. And I just interchanged these 2 points if you observe, isn't it? Hemophilia A is caused by a deficiency of the factor 9? No, it is caused by factor 8. Okay. Which of the above statements are incorrect? Which of the above statements are incorrect? All are incorrect. Is it clear? D is the right answer. Got it? Now, moving on to the next topic. What are India's plans for a quantum satellite? Quantum satellite. Okay, let us see what it is. Before we discuss about quantum satellite, we should first know about the National Quantum Mission. National Quantum Mission. I hope you might have studied about the quantum computers. One practical problem with science and technology current affairs is this is a small news, like say for example, okay, this is a 20th UCAN session. In every session there is something about gene, but in every session I cannot explain what is gene, what is DNA, what is chromosomes. Same way, in several sessions I discussed about quantum computers or quantum technology, but in every class I cannot explain what are quantum computers. In the science and technology current affairs, we have this small limitation. I hope you have some basics about the quantum computers, but still I will try to explain. Let us see what best we can do to understand this. Clear? Yes? Okay. So, what is quantum computers? To understand quantum computers, first tell me what are the quantum particles? What are the quantum particles? Quantum particles means the smallest particles, okay, are called quantum particles. Like it can be electrons, protons, neutrons, okay, or photons. Photons. The smallest unit of, okay, either the matter like this or energy, photons. They are called quantum particles. We use quantum particles, that means we use electrons, protons, neutrons or photons. If we use photons as bits, what is bits? 0 and 1 are the bits, isn't it? Instead of 0 and 1, we use photons. Okay, we use photons as bits. Then they are called qubits. Because we are using quantum particles as bits. Is it clear? Qubits means what? Quantum particles as bits. Is it clear? A computer, okay, that use quantum particles as bits, that is it uses qubits instead of the classical bits, is called as a quantum computer. Okay, I hope it is clear. Quantum particles means the smallest units of either the matter, that is electrons, protons, neutrons, subatomic particles, or the smallest units of energy, that is photons. These are quantum particles. If we use, okay, quantum particles as bits, then they are called qubits. If we use quantum particles as bits, they are called qubits. A computer that uses qubits instead of bits is called as a quantum computer. I hope it is clear till this point. Okay. Then, National Quantum Mission approved in the year 2023 with a budget of 6,000 crore rupees. The mission aims to make quantum technologies affordable and scalable. What is the target of the National Quantum Mission? Remember this point, please. What is the target of the National Quantum Mission? Okay, to make the quantum technologies affordable and scalable. Scalable means we should be able to manufacture The quantum computers at large scale, scalable production. I mean, we should be capable of increasing the production according to the needs. Okay. For a wide range of applications like communication and encryption. Encryption means what? Secret messages. Okay. Sending secret messages from one quantum computer to the other quantum computer. Is that clear? Okay. What is National Quantum Mission? It is a mission approved in the year 2023 with a budget of 6,000 crore rupees. And the target of the mission is to make the quantum technologies affordable and scalable. Cost should be reduced, and also we should be able to manufacture them at a large scale. That is the target of this particular mission. Remember this. Okay. What is quantum satellite? Okay, forget about quantum satellite. In general, when you send any satellite, do you need communication between the ground station? I mean, for example, ISRO launches some Exposat, okay, or some Chandrayaan 3, or some Mangalyaan 2, or Gaganyaan. ISRO launches any one satellite, let us suppose. Do we need communication between, okay, do we need communication between the ground station and the satellite? Yes, all of you. Do we need communication? Yes. Okay. Now, what is a quantum satellite? Okay. If you use quantum, okay, internet, I mean, if you use quantum technology for this communication, not a normal internet, quantum technology based internet to communicate between the ground station and the satellite. If the satellite is communicating with the ground station through quantum technology based internet, I repeat, if the satellite is communicating with the ground station with a quantum technology based internet, that is called quantum satellite. Is that clear? Not radio waves. If it is communicating through radio waves, that is a normal satellite. Is it clear? Okay, Ganesh, a normal satellite will communicate with the ground station using radio waves. But quantum satellite will communicate with the ground station using a quantum technology based internet. Clear for all of you? Okay, Kiran, Binita, Megha, Nishant, Pavan Kalyan, Munna, Ganesh, Rahul. Clear for all of you? Right. A normal satellite will communicate with the ground station using what? Everybody. A normal satellite will communicate with the ground station using radio waves. But quantum satellite communicates with the ground station using quantum satellite communicates with the ground station using quantum satellite, quantum technology based internet. Then we call it as quantum satellite. India plans to launch a quantum satellite in the next 2 to 3 years. Did we already send a quantum satellite? No. We are doing research on that. We don't have a quantum internet at the current situation. Is it clear? We are working on that. In the next 2 to 3 years, we are planning to send a quantum satellite. A quantum satellite is a communication satellite that utilizes quantum physics principles to secure the communication. To get communication with the ground control, it will use quantum physics principles, quantum based internet. Is it clear? No, not quantum optical. There is nothing called quantum optical beam. Quantum based internet is enough. Done? Clear till now? No. Okay. Let us suppose the satellite is sending information to the ground station using quantum technology based internet. But meanwhile, if anybody is trying to hack this particular system. Like okay, if anybody is try to hack this particular system, then what happens? Okay, we need secure communication. Do you agree? We need secure communication between the satellite and the ground station. So we use a technology called as quantum cryptography. Crypto means what? Secret, hidden. We use quantum cryptography. Okay. Now we have to understand what is quantum cryptography. Quantum key distribution, QKD. Okay. Quantum key. What is key? Okay. Key means like a password. Is it clear? Key means like a password. Quantum key means what? Quantum technology based password. Quantum technology based password. Okay. Now, I will try to explain this. Listen this carefully. Okay. Tell me, what are the qubits? All of you, please. What are the qubits? Let us suppose they are called photons. Is it clear? They are called photons. Not only photons, you can also use electrons and protons also, but let us assume that we are using the photons. Okay? Yeah. Qubits means quantum bits, but what are the quantum bits, Monu Chowdhury? Okay. Quantum bits are photons or protons or electrons or neutrons. Is it some quantum particles? Then, now look at here. Okay. This is our password. Did you understand? This is our password. Is it clear? What is this? Okay. This is the arrow marks indicate the orientation of photons. Up, down like that. Is it clear? So this is the password and we can call this as quantum key. Is it clear? We call this as quantum key. Clear? Okay, what is quantum key? It is a password and the password is nothing but, okay, a particular pattern of. The quantum key is a particular pattern of photons. That is called quantum key. Right. Now let us suppose I am trying to hack it. Then what happens? There will be some change in the orientation. Clear? If I try to hack it, the quantum key, the orientation of the photons in the quantum key will change. Change in the orientation of the photons. Right? This change can be detected. Is it clear? We can detect this change. Right? We can detect this change. Okay? Okay. If my quantum key, for example, I know that it is up, down, up, down, down. But it became up, down, up, down, up. Means one photon changed. I hope it is clear. Okay. One photon changed. Instead of down, it became up. Is that clear? Clear till now? Now, if this orientation changes, the key changed. When the key changes, we can detect that somebody is trying to get access to the communication. Is it clear? Somebody got access, somebody is watching this communication. We can understand that. Is it clear? And we can stop the communication. I sensed that somebody is hacking it and I can stop the communication. Is it clear? Yes, it is a secure key. Okay, if the quantum key changes, that is if the orientation of the photons in the quantum key changes, I can sense that somebody is hacking this communication and I can stop the communication. Not only that, I can also measure. I can also measure this. It means, let us suppose, answer this all of you. If the orientation of a single photon is changed, or if the orientation of four photons changed, several photons changed, in which case there is more data theft, in which case you have to understand that more information is stolen. Yes? One photon change in the orientation or several photons change in the orientation. Second case. So we can also measure the degree of the threat. Look at here. Prepare and measure protocols. They focus on measuring the unknown quantum states. What is the unknown quantum state? Look at here. Okay, this red color one is nothing but, okay, this red color one is nothing but the unknown quantum state. I mean, this is not something that I kept in the key. Is it clear? This is not something, this red color one is not something that I kept in the key. In my key, it is having a downward orientation, but now it is having upward. It is an unknown quantum state. Is that clear for all of you? The focus on measuring unknown quantum states, they can be used to detect the, okay, eavesdropping. Eavesdropping. It means what? Somebody is observing it. Somebody is peeping inside. Eavesdropping means what? Hacking. Trying to get access or peeping into the information. Is it clear? It is used to detect the eavesdropping as well as how much data was potentially, okay, intercepted. Okay, I hope it is clear. So, see, I had one particular quantum key. I will explain point by point. Listen carefully. I created a particular quantum key and this is my quantum key. In my quantum key, I kept a particular pattern of qubits. Is it clear? I kept a particular pattern of qubits. Now, I detected one unknown quantum state. The one which is supposed to be down is now up. I found an unknown quantum state. It means somebody is trying to hack. Somebody is peeping in. There is eavesdropping. Eavesdropping. Is it clear? Okay. Then what I will do? I will measure how many qubits changed. I will measure how many qubits changed. The more qubits changed, the more data theft. Okay. So this is a method to secure communication using quantum technology based internet. Is it clear? This is one method for secure communication using quantum internet. Second one is quantum entanglement. What is quantum entanglement? Quite interesting. Let me explain this. Okay, complete focus here, please. Quantum entanglement. Okay. No, we do not have a quantum computer, Ganesh. As of now, it is just hypothetical. On a hypothetical possibility, we are spending 6,000 crore rupees. Okay. And most importantly, some physicists, some mathematicians say that, okay, quantum technology is, maybe it is never possible also, but we strongly believe that it is possible. And we are believing that in the next few years, we are going to make a quantum computer and quantum satellites and all those things. Now, coming back to this, I'm explaining a concept called as quantum entanglement. See, I'm trying to give you all the basics to understand this, but how much ever I explain the basics, okay, all basics of all the news articles cannot be covered in a current affairs class, okay, so that you must keep in your mind, right? Okay, so now let us try to understand what is quantum entanglement. See, let us suppose I have a quantum computer. Is it clear? In that I have qubits, isn't it? That is electrons or photons, for example. In that I have photons. And say I am in Hyderabad. Is it clear? My quantum computer is in Hyderabad, right? Then you have another quantum computer. Is it clear? That is also having qubits. That is also having qubits. What are they? They are also photons. And let us suppose you are in Delhi. Is it clear? It means we both have, okay, hundreds of kilometers distance between these two quantum computers, isn't it? We have hundreds of kilometers distance between the two quantum computers, right? Yes. But still, okay, there is some kind of connection between the two. I mean, there is something like a channel. Okay. There is something like a channel between the two. Okay. This channel is called quantum entanglement. Is that clear? That channel is called quantum entanglement. Then you may easily ask me, madam, what is that channel? Yes, Einstein calls it as a ghost. Okay. Einstein called it as a spooky action in the sky. Einstein called this as a spooky action. Spooky action means what? Okay. Spooky action means some mysterious activity, like mysterious. Got it? So, okay. You may tell me that we are not understanding the quantum computers very well. You may say like that. No wonder. Okay. There are very few people who actually understood what are the quantum computers, and we do not have a quantum computer as of now. And Einstein himself called it as something mysterious. It means we don't know what is the nature of that channel. It is not you. It is not I. It is not the one who wrote this newspaper article. It is even Einstein said that it is a mysterious channel between the two. Because of this mysterious channel, if you change your photons, I mean the photons in your quantum computer changes. Okay? Okay. Like if the photons in your quantum computer changes, my photons also will, though they are hundreds of kilometers apart. Did you understand? The two quantum computers the two quantum computers are hundreds of kilometers apart. But still, if you change something about your photons, my photons also will change. I mean, they both are interconnected. Not only hundreds of kilometers, thousands of kilometers apart also, the quantum particles are interconnected. How are they connected? What is the medium through which they are connected? We do not know. I mean, not you, not me, not the scientists. We all, the scientific community, do not know. I hope it is clear for all of you. No, not wave function. It's not a wave. It is not a wave. Okay. And okay. If you really discover it, tell me. So I will try to arrange a prize for you. Actually, the nature of this quantum entanglement, we do not know. Is it clear? Quantum and supercomputers. We'll definitely do Antara in one more class when I do supercomputers, or in the comprehensive science and technology course. Right now I am finding it challenging to complete about the quantum computers itself within the allotted time. We just have 10 more minutes. So I'll definitely explain supercomputers in one more UCAN session. Let us now focus only on the quantum computers. Is it clear? Yeah, quantum computer itself. Okay, but that is not a wave function. Why are they so fast? Because of the quantum entanglement. They are fast because of the quantum entanglement. Then what is quantum entanglement? some mysterious connection between the quantum particles at a large distance. Why are they so fast? Because of the quantum entanglement. What is quantum entanglement? Some mysterious connection between the quantum particles at large distance, thousands of kilometers apart. But still, they are connected. If you change this, that will change. That channel is called quantum computer. The information passes through this channel. Is it clear? Okay. The communication happens through this channel. I mean, I am sending mail to you from Hyderabad to Delhi. I am sending a mail through to you through this channel. I hope it is clear. So therefore it is very fast. The nature of this quantum entanglement is like that. Okay? Clear till now? So, now look at it. Focus on quantum states in which two objects are linked together. If the eavesdropper means somebody who is trying to peep into your information, somebody who is trying to hack, okay, access a previously trusted node. Node means one computer, okay. Node means one computer, okay, or one processing unit is called as a node. Previously trusted node means what? Not corrupted. I mean, nobody hacked. Okay, secure node. And changes something. For example, can I call my processing unit, my computer as one node? Yes. Currently it is secure. Good. Now an eavesdropper is trying to hack it. Fine. Then what happens? Okay. Uh, like uh, uh, then what happens? The other involved people will get to know about this. I mean, in Delhi, you will know. I mean, you can call me and tell me that your system is getting hacked. Please check. Did you understand? Why? Due to quantum entanglement. If the hacker is trying to change this, then your photons are also changing. Is it everybody using this connection will come to know about it? This is one more method of secure communication. Is it clear? One is through measuring the amount of change in the qubits. Second one is by observing the changes in the quantum entanglement. Is that clear? Okay. I repeat this point just one more time because it is complicated. Listen carefully. Let us suppose I am using a quantum computer and that is called as a node. Is the first point clear? Let us suppose I am using a quantum computer and we are calling that as one node. Second point, in that node I am using photons, that is quantum particles. Is that clear? In my node, in my quantum computer, I am using photons, that is quantum particles. Is that clear? Yes. Currently, it is a secure node. I mean, nobody hacked it. Currently, it is a secure. Currently, it is a trusted node. Very good. Fourth point. Now, somebody is trying to hack it. Now, somebody is trying to hack my node, my quantum computer. Then what happens? My photons are changing. The photons in my quantum computer are changing. Is that clear? Then what happens? Through quantum entanglement, the other people connected to me in the quantum internet, okay, can detect that somebody is trying to hack my node. Can detect that because their photons are also changing. How do they change? Don't say that I did not understand how their photons are changing. No problem, nobody understood that. So we are calling it as a mysterious channel through which both are connected. I hope it is clear. Right. So these are the two ways in which we can send the information communication in a secure manner. So in the quantum satellites, okay, in the quantum satellite, we do the communication in a secure manner using these two types of security measures. Is it clear? Using these two methods, we can communicate. The quantum satellite can communicate safely with the ground station. Using these two methods, the quantum satellite can communicate safely with the ground station. Clear till now? Next, global efforts in quantum communication. China has largest quantum key distribution network with 3 satellites and ground stations. They are experimental. In India, the researchers have identified Hanli in Ladakh as a prime location for doing these experiments, where we are trying to communicate over 500-kilometer distance. Okay? In Ladakh, we are doing an experiment to communicate between two quantum computers located 500 kilometers apart. If this is successful, then we can try to launch a quantum satellite, because there the distance will be more than 500 kilometers. Is it clear? Eavesdropper means 10 times I told you, hacker, somebody who is trying to hack the system. Okay, right. What are the challenges in quantum satellites? Current QKD systems are costly, hardware dependent, and prone to denial of service attacks. What is denial of service? It is a type of cyber attack. Okay, they're prone to cyber attacks. I mean, we still do not know this completely, isn't it? We still did not clearly understand what is quantum technology, what is quantum internet, quantum key, or quantum entanglement. We still did not have complete knowledge on this. So therefore, still this kind of communication is prone to cyber attacks. Future potential. Advances in quantum communication could lead to revolutionary changes in data security. It means in future, we can transfer the data in a very secure manner. Is it clear? Ishwar, normal computer, classic computer uses zeros and ones. Quantum computer uses photons. Your classical computer uses zeros and ones. Your quantum computer uses photons as qubits. Photons as qubits. That is the difference. I hope it is clear, Ishwar. Okay. Right. So, what is the future potential? In future, we will be able to communicate in the data. We will be able to send the data in a very secure manner. But the real world implementations remain a decade away. It means till here, till this particular time, okay, we do not have a real time application. It means it is all only hypothetical. What is quantum entanglement? We don't know. It is mysterious. Okay, how to use photons as qubits? Not very clear. Do we have a quantum computer? No, not yet. Is it clear? It is all hypothetical. So if you do not get complete clarity on this, that is the nature of the topic, not your fault. Is it clear? The real-time implementations, okay, are almost a decade away. So probably I will be able to explain this in such a way that you all will understand maybe after some 5-6 years. Is it clear? So this is about quantum satellite. Okay. So as it is already 10 p.m. Okay. This is the last topic we discussed in this session. There are a few more topics which I will cover in the next UCAN session, and I will give you some 30 to 40 seconds time answer this question. Answer this question. Telugu cartoons 2024 entire year current affairs will be there. Okay, that is 1 year current affairs roundup will be there. Okay, before the prelims we do that as a separate program, right? Whole world live and grow with trust and cooperation. Then we don't need all these things, Monu Chowdhury. Okay, but the trust and cooperation is not there. All the people are becoming selfish. So we need all the secure communications. Is it clear? Okay, right. With reference to India's plan for quantum satellite, consider the following statements. The mission. Which mission? Okay. Which mission? The quantum mission. Is it clear? National quantum mission. aims to make quantum technologies affordable and scalable for wide range applications. Correct. Quantum satellites use principles like entanglement and quantum measurements to prevent eavesdropping. Correct. India has already implemented the world's largest quantum communication network. No, not yet. Okay. 1 and 2 only is the right answer. Okay. See, in science and technology, because all these are conceptual topics, it definitely takes time for explaining one particular article. And also you can notice that, okay, the number of articles that are important are also quite less when compared to the other subjects. That is the nature of science and technology. Okay, and this is monthly current affairs program, but before the prelims we will also launch a separate program for the 1 year current affairs roundup. Okay, and also we have comprehensive batches for science and technology and all the other subjects. In the comprehensive batch for science and technology, we will cover all the topics from the basics. In this class also, almost if you observed, I explained every word that I used. What is eavesdropping? What is quantum entanglement? What is quantum computer? What is gene? What is the link between gene and protein? What is transduction, transformation, conjugation? I tried to explain the meaning of every word I use, but in a comprehensive course, I can do it, okay, in a much more systematic manner. Okay, that's all for this session. Thank you so much for your active participation. Okay, good night, take care, bye bye.